Hi, I'm John Paul Martin, the Warning Coordination Meteorologist with NOAA's National Weather Service in Bismarck, encouraging you to attend skywarn spotting in your community when the National Weather Service comes out for that, or viewing severe weather safety online at National Weather Service website, or through videos like this. National Weather Service website, www.weather.gov. And I had to call them back and say, no, I think you got 1.25 inch diameter hail. They said, no, it's 1.25. And I said, yeah, but see, you started at the 1 inch mark. You got to subtract that off. So be careful with that. I don't want you getting embarrassed. Now, here's a whole bunch of smaller hail up in Belfort. Rolette County, Turtle Mountain, Turtle Mountain, yes. A whole bunch of, well, looks like smaller hail piled up. Look at that. It's deep. It's deep. One thing I want to say about hail is, and this is a hard one. The definition of a severe thunderstorm changed here a few years ago. The definition of large hail was a penny-sized hail, which was 3/4 of an inch. 3/4 of an inch in diameter. But people complained. They said, you're interrupting my favorite TV program too often for this 3/4 inch hail. I'm trying to watch Dancing with the Stars, and you're interrupting me all the time. And so the National Weather Service took note of that. And then they went to insurance companies and determined that penny-sized hail really didn't damage your car, dent it, crack the window, or anything like that. And so the National Weather Service agreed that, yeah, we need to increase the size of the hail to 1 inch in diameter. What we talked about here in North Dakota, in a little bit of opposition to that policy, was, well, what about the farmers? I mean, our wheat is being destroyed with 3/4 inch hail, especially if you got a 40-mile-an-hour wind with it, right? And the answer back was kind of a legitimate answer. They said, well, what can the farmer do to protect the crop? You can't do anything other than hail insurance, right? So that was not, in the end it was determined that, no, we need to move to 1 inch hail. And so we did. But the point is, you can have pea-sized hail. You could have pea-sized hail, little bitty tiny hail piled this deep, and yet I'm going to tell you that was not a severe thunderstorm. It's going to be hard for me to tell you it was not a severe thunderstorm, but I'm going to have to tell you it was not a severe thunderstorm. I'm not going to like having to tell you that. Right? What about when you're reporting the size of hail? When you have a whole bunch of hail in your backyard after a thunderstorm, what size do you report? Well, you have a whole bunch of different sizes. What do you think you report? You report the size of the largest stone, the biggest one, absolutely. If you have pea-sized hail, and that's the biggest you have, report pea-sized hail. But if you have pennies, forget the peas. If you have nickels, forget the pennies. If you have quarters, forget the nickels. If you have golf balls, forget the quarters. See what I'm saying? Take the largest stone and report that. Now if you want to say, hey, most of it was smaller than that. That's okay, but I need the largest stone, is what we're after. A few things you need to get a thunderstorm started. You need moisture, preferably in the low layers of the atmosphere. Moisture, think of it as high humidity. So we need to get moisture. Then we need to lift the moist air. We need to get that moist air rising a little bit. To get these air parcels, these moist air parcels, we have to get them rising. And then finally, that moist air parcel, once we get it rising, we want it to keep on going until we get a cloud to form, or maybe a thunderstorm. Moisture. How do we get moisture up in North Dakota? From the south. From Louisiana, the Gulf of Mexico. Over several days, that southerly flow brings that moisture up in North Dakota. There's a thing called evapotranspiration. It's been shown with studies in Saskatchewan that wheat field is putting out a whole bunch of water into the atmosphere, taking a whole bunch of water out of the ground and putting it into the atmosphere. So farming puts water into the atmosphere. Lift, how do we get the lift? Fronts, cold fronts, warm fronts. So on the right is a cold front. The leading edge of colder air is coming in. Colder air is coming in. The warm, moist air is being pushed up and over the cold air, and we get clouds and shower thunderstorms to form. Now on the left-hand side is a warm front, and with a warm front, the warm air is more gently easing up and over the colder air. Okay, it's not as abrupt as what it is over here. This is a sharp vertical rise in the warm air. The cold air is pushing that warm air up. Here, the warm air is gently coming in up and over the colder dome. So on the right is where you get showery weather, rain showers and thunderstorms. On the left is more conducive to, you might get rain for 4, 5, 6 hours straight, a steady light rain type thing as a warm front comes through. So that's the lift. And then finally, we need the atmosphere to be unstable so that I can get a thunderstorm to form. I want this moist parcel of air to keep rising. So here, for example, you know this, that warm air is lighter, it's less dense. And so warm air rises, and cold air is heavier. It's more dense, so it sinks. All right? So we have a parcel of air here near the ground. It's been heated up because the sun is shining on that black parking lot all day long. So the black parking lot is heating up more than the grass area all around it. So the grass area all around it, the temperature is 80 degrees, but these parcels of air over the parking lot are 95 degrees. The parcels of air over the parking lot are going to want to rise. And as you lift air, it's going to cool off. So its temperature now is down to 68, but it's still warmer than the air all around it. It's down to 40, but it's still warmer than the air all around it. It's down to -4, but it's still warmer than the air all around it. As long as it's warmer than the air all around it, it's going to keep rising. If this parcel of air is colder than the air all around it, now it's going to sink back down to the ground. Unstable atmosphere is when parcels want to keep going up. Stable atmosphere is where the atmosphere is pushing down, preventing, oh, I don't want you coming up here, stay down there. In the wintertime, out of a smokestack. You see smoke rising up out of a smokestack or a chimney, it rises a little bit and levels off. That's a stable atmosphere. That warm air coming out of the smokestack cools off, and now it's colder than its environment, so it wants to sink back down. When you see smoke coming out of a chimney or a smokestack and it just rises way high above the smokestack, that's an unstable atmosphere. It's warmer than the air around it, so it keeps on rising. Stable atmosphere is bad in Los Angeles, California, because all the smog, the fog and the pollution is trapped over the city, and it's that yucky film over Los Angeles, California. And if you're an elderly person or a young person and you have lung problems, you need to, you don't go outside today because the pollution index is whatever it is. Thunderstorm life cycle. Every thunderstorm goes through a life cycle, just like you go through a life cycle. Towering cumulus stage, the thunderstorm is just developing. Almost all the motion here in the cloud is upward. Very little, if any, rain falling out or anything like that now. Again, we're just developing, just forming. Towards the end of this stage is where you get your first flash of lightning. It's the mature stage. It's what we call the weather stage. What do you need to get a thunderstorm? When do you say, oh, that's a thunderstorm now? Do you need rain to get a thunderstorm?
Thunder.
Even one thing before thunder. A flash of lightning. Lightning comes first. Lightning causes thunder. All right? A flash of lightning causes thunder. You ever see a flash of lightning and not hear the thunder? All the time, right? What's happening there? You see a flash of lightning and you don't hear the thunder. What's happening there? It's what?
Might be too far away.
The lightning struck so far away from you that the sound never got to you. You saw the flash of light, but the sound never got to you. By the time it got to you, it was too weak, you couldn't hear it. It's like if I had a flashlight here, I turned the I gotta start bringing a flashlight. I've been saying that for 5 years now, Mary, and you didn't even bring me a flashlight today. If I had a flashlight and I turned a flashlight on, everybody in here would see it. Even Matt sitting way in the back would see the light. But if I clap my hands, maybe you would hear it, maybe you would hear it, but maybe you didn't hear it because you're just too far away. Every lightning flash causes thunder. It's just sometimes you're too far away to hear it. My father told me, Johnny, that's...
Thank you for watching. Continued in part 6. Videographed by Matthew Kronberger. If you enjoyed the presentation, comment and subscribe to my YouTube channel at Matthew Kronberger, Bismarck, North Dakota.